Hey guys, and thanks Roy for the incredible presentation. I don't know how I'm going to follow up with that, but really excited today to talk to you guys about intents. And specifically, what does the next generation of intents look like? And why do I say next generation? What's wrong with the intents of today? And so the problem with intents is that they're currently fragmented. If you use CowSwap or Uniswap X, it looks very pretty behind the scenes, and I love using those apps, especially hearing the moo sound every time I make a trade. But how on the back end, what's happening is that I sign a message, and then my intent, which is just a signed message, gets stored in a centralized server that, let's say, CowSwap maintains. Solvers who are whitelisted by CowSwap are able to access and read it from their centralized database, and then come up with bids. Those bids are sent to CowSwap, and then CowSwap runs an auction to determine what gives the maximal surplus. And so we see these two centralized points of failure, where you have this storage process somewhere for intents to live, and then the selection process where CowSwap is selecting the intents. And I think, honestly, this works fine. Like, it's a great app if you guys have used CowSwap. I use DeFi Llama for trading, swap.defi Llama, and which is a meta aggregator. And CowSwap is like 80% of my 80% of the time, it's the best trading route. But the problem with this is it doesn't really scale. Sure, you have CowSwap with intents, you have Uniswap X with intents, but what about a future where every application becomes a every smart contract becomes an intent-based app? In that scenario, what we're going to have is that all of these are going to have their own isolated mempools or so, and they won't be able to compose with each other because the intents in each one can't read from one another, and the solvers are siloed. And that's why we say that intents are fragmented. So I have this new proposal for a modular intent stack which can solve this. And specifically, we need three things. One is a representation, ways to represent these intents across applications so that we're talking the same language. Two is propagation, a way for intents to live and be propagated to solvers. And three is selection. How do you actually choose the selection of these solvers? And I think it's notable that it's okay for these things to be off-chain, but they absolutely must be verifiable, so everyone can verify that they're running properly as they should. And two, they must be censorship resistant, because if they can censor you, then what's the whole point of this blockchain thing? So first, let's talk about representation. Right now, we've actually seen boundless strides made by Across and Uniswap with ERC7683. Who here has heard of ERC7683 on crypto Twitter? Okay, I see a few of us. I'd love to hear it. So what they're doing is they're describing a way to represent cross-chain intents. And what this means is that if you want to swap value from one chain to another, so any cross-chain swap, you can represent, okay, I'm going to have this much, like these types of tokens on this chain, and I want to receive these tokens on my destination chain. And they gave away a standard representation of seeing that, so that when solvers look at these cross-chain intents, then they're going to say, oh, I don't need to manually integrate with each type of representation. Instead, there's a consistent format. Think of this as the ERC20 for cross-chain intents. And I think that's actually really powerful, because even though it's pretty simple in how it looks, it means that solvers don't have to spend, solvers can just integrate across the stack. And this is the first step we can take towards composable solving and composable intents. The next thing I want to talk about is propagation. And this is a bit more complicated because you need a decentralized way for intents to live and for intents to propagate. And you can kind of think of it as intents are, these intents are usually signed messages, right? And they can't be executed on their own. They need a third party to combine them with another intent and settle them. In the process, they usually become a transaction, and then they're actually settled after being gone through the mempool. And so if you think of it, we almost need something like the mempool in Ethereum, either public or private, where intents can live. So let's start off with just understanding what is the current state of things. And I talked about this earlier with the cow swap example, which is right now we have a centralized server where all of the intents are living. And then these solvers are reading from, who are usually whitelisted or at least bonded, are reading from this server. But we don't like that because it's you can easily censor, it's not verifiable. We want to make sure that we're actually getting a decentralized solution. So another possible solution to this is actually repurposing the Ethereum mempool. And you might think, what does that mean? This goes a bit into the weeds, but effectively, instead of having the Ethereum validator set share transactions, they can also share intents. Now, what are some problems that may exist with this? The first one that comes to mind is DOSing. So if I want to send a transaction, I have to pay gas, right? And if I pay gas, then this almost serves as a way to prevent sibling. Serves as a way to prevent sibling because there's only so much gas that I can spend. I can't just constantly be streaming transactions. And so it works okay if we serve intents with and we're combining it with some form of transaction. This is what Across does right now. If you want to send a cross-chain transfer on Across, then you actually have to lock up your collateral in a transaction, and they use the Ethereum mempool for their intents, to transfer intents. But the problem with this is exactly what Roy talked about earlier, which is we want a gasless experience. So, and especially with intents, which may or may not get solved, we definitely need a gasless experience. And that leads to DOSing, as we see in scenario 2, right over here, which is that I can easily just send a bunch of intents. Ethereum validators won't be able to verify that these intents are actually meaningful, and then nodes are going to get run over, especially our solo stakers, which we definitely don't want. So the third solution is a decentralized version of our first one, where what if we could have a server that you can read from anytime, but we made that any solver can read from, but we made sure that the server is going to be decentralized. And what this looks like is you can have a low latency data availability layer, which is purpose made for censorship resistance, right? The whole point of DA is that anyone can read, can read from a DA layer or write to if they're willing to pay the gas and storage costs. And so if you have a layer that's purposely built for censorship resistance, we can use that to store intents, and then solvers can learn to can read from it, and we can especially have a lot of solvers who are they can only integrate with one place. And again, assuming we want a whole a future where every smart contract is an intent-based app, then this needs to be hyper scalable, probably more scalable than Ethereum, because as you know, people joke that limit orders and intents are kind of the same thing. Not intents are broader, but the analogy still holds that there are probably 10 times as many canceled orders, limit orders, than there are actual orders that are settled in an order book. And the same thing here. We're going to see probably 10 times as many intents as actual transactions that get solved, that get settled. And so what this means is that we need a hyper-scalable data availability network. And for that, we need horizontal scaling. And right now, EigenDA is the only horizontal scaling solution, DA solution out there. Finally, let's talk about the selection process. Remember that right now CowSwap runs a centralized auction. And so what you can do is instead run a leaderless auction. Paradigm and Sorella Labs actually launched a paper about this. Highly recommend reading it. Happy to share afterwards with anyone. But Sorella talks about these leaderless auctions where it doesn't matter, everyone has access to all of the information, and then they're able to come to consensus very quickly about which is the best intent or like best bid to settle these intents. And this can be really useful for an end-to-end solution like CowSwap, or a more modular solution that could settle a bunch of different intents together. So why is this relevant to EigenLayer is that we see that the easiest way to create these off-chain verifiable solutions like leaderless auctions is via an AVS. And happy to talk after if anyone's interested in that. So if you take a picture of any one slide, I recommend it being this slide because pandas are adorable and awesome. Yeah. What I want to say is that intents and then are great, but if you combine them with intent standards, low latency DA, and auctions, then what you can do is create this whole new world of composable solving. And I call it composable solving because this is how solvers are able to like work together and compete to actually create a more unified intense experience. So I'll leave you with one last word, which is intent-based apps. They don't really scale, but intents, they can. We just have to help them scale with some verifiable off-chain infra. So that's all on my end. Thank you, guys.